Okay, so this is going to be practice for using the square root method. So starting off on number 1, it says, which of the following are perfect square trinomials? It wants us to circle them and write their factors. Okay, in order to determine if we have a perfect square trinomial, we first have to take our b value, and we want to divide that by 2, and in this case I get 2. So that means the factors for this would be x plus 2 squared, if it's a perfect square trinomial. Now, when I take this 2 and I square it, I get 4, and that's my value that I have right here, so that means that this is a perfect square trinomial. Okay, on this next one, we can go ahead and eliminate it because in order for it to be a perfect square trinomial, our c value cannot be negative. And you can see that this one is negative, so therefore it is not one. Okay, on our third one here, again, we're going to take our b value, divide it by 2. So we see that that is 5, so that's x plus 5 squared. So when I square 5, I get 25, and therefore it's not 26, so I cannot determine that this is a perfect square trinomial. Okay. All right, for the next one, again, I'm going to divide by 2, so that would give me x plus 6 squared. But 6 times 6 does not give me 12, it's 36, so I know that this one's not going to work. Okay, on this one right here, again, we're going to divide by 2, and we get that this is x minus 6 squared as the factors, and negative 6 times negative 6 does give me a 36, so therefore this one is a perfect square trinomial. All right, last one for number 1, we're going to take 24, divide it by 2, where we would get 12, so we'd have x plus 12 squared, and 12 times 12 gives me 144, so that means that this one is a perfect square trinomial. All right. Okay, so for the next couple of problems, we are going to write the factors of these perfect square trinomials and solve. So since we already know that they're perfect square trinomials, that's going to make things a lot easier. So over here, we have, for number 2, x squared minus 10x plus 25. Since it's telling me that this is a perfect square trinomial, I know I have to take my b value, which is negative 10. I'm going to divide that by 2, which gives me negative 5. So that means that my factors for x squared minus 10x plus 25 is going to be x minus 5 squared. And that equals 81. So now that I have this, I can now take the square root of each side. So that's going to cancel that out. I'm going to come down here and finish it. So that means I would have x minus 5 equals plus minus 9, because the square root of 81 is 9. All right, and now to solve for it, I need to add 5 to both sides. So that's going to zero out. So I'm going to have x equals 5 plus 9 and x equals 5 minus 9. So therefore my solutions are 5 plus 9 gives me 14 and 5 minus 9 gives me negative 4. Okay. Moving on to number 3. Again, all I need to do is take this negative 12 and divide it by 2, which gives me negative 6. So then I know my factors are x minus 6 squared, since this is a perfect square trinomial. And then I'm going to bring down the 49. All right, so now I have it set up to where I can take the square root of each side. So that's going to cancel this out. So now I have x minus 6 equals plus minus, and the square root of 49 is 7. And now I just need to add 6 to both sides so that I can solve for x. So I have x equals 6 plus 7 and x equals 6 minus 7. So therefore my solutions are x plus 7 gives me 13 and 6 minus 7 gives me negative 1. And those are my solutions. Okay, so moving on to number 4. All right, again, I am going to take my b value here and divide it by 2. So that's going to give me 1. So then I have x plus 1 squared equals 8. And now that I have it set up like this, I can take the square root of each side. So this is going to go away. So I have x plus 1 equals plus minus the square root of 8. Since 8 is not a perfect number, I'm just going to leave it just like that. And then to solve for x, I just need to subtract 1 from both sides. So my solutions are x equals negative 1 plus the square root of 8, and x equals negative 1 minus the square root of 8. Okay, number 5. All right, again, I'm going to take my b value and divide it by 2, and that gives me 8. So that means that my factors here are x plus 8 squared for the perfect square trinomial. And then I'm going to bring down the 27 here. And now I have my equation set up so that I can use the square root method. So we're going to square root each side. So that goes away. So then I have x plus 8 equals plus minus the square root of 27. And I'm going to leave it like that since 27 is not a perfect number. And now to solve for x, I just need to subtract 8 from both sides. So that gives me x equals negative 8 plus the square root of 27, and x equals negative 8 minus the square root of 27. And those are my 2 solutions. Okay, so flipping over to the back side. All right, so for number 6, this time I want to get my equation set up so that it looks like x squared equals c, and then I can do the square root method. So in order to get mine to look like this, I'm going to have to add 2 to both sides. So then that gives me x squared equals 28. And now that I have it set up where it looks like this, I can go ahead and take the square root of each side so that I get x equals plus minus the square root of 28. So therefore x equals the square root of 28, and x equals negative square root of 28. Okay. So number 7 is set up already like this right here, so I can go ahead and take the square root of each side. Again, that cancels out, so then I get that x equals plus minus the square root of 18. So therefore my solutions are x equals the square root of 18 and x equals negative square root of 18. All right, so moving on to number 8. Again, I want to get my equation set up where I have my c value on one side and the x squared on the other. So in order to do that, I need to subtract 9 from both sides. So then that gives me x squared equals negative 9. Okay, so typically here we would go ahead and take the square root of each side, but see how my c value is negative here? And when it's negative, I can't take the square root of it, so therefore there are no solutions. Okay, moving on to number 9. Again, my equation is set up where I have my c value on one side and the x squared on the other side. But again, I can see that my c value here is negative, and we can't take the square root of a negative value. So again, we have no solutions. Okay, moving on to number 10. So this one's already set up where we have x plus or minus some number squared equals another number. And when it's set up like this, then we can go ahead and take the square root of each side as well. So that's what we'll do here. We'll take the square root of x minus 5 squared and 7. So for the x minus 5 squared, the squared's going to go away. So we have x minus 5 equals plus minus, and since 7 is not a perfect number, we'll just leave it as the square root of 7. Okay, and now to solve for x, we're going to add 5 to both sides. So we have x equals 5 plus the square root of 7, and x equals 5 minus the square root of 7. Okay, number 11. So if you'll notice, number 11 is just like number 10, and it's set up in the form that we need it to be in order to take the square root of each side. So we'll go ahead and do that. Is take the square root of each side. This will cancel out. So then I have x minus 3 equals plus minus the square root of 18. And now to solve for x, all we need to do is add 3 to both sides. So our solutions are x equals 3 plus the square root of 18, and x equals 3 minus the square root of 18. Okay, now number 12. So 12 is almost like what I need it to be in order to use the square root method. The only thing I have here is that's different is where I'm dividing on this side by 5. And I want to get rid of that. So what I need to do is just multiply each side by 5 since multiplication undoes division. So that's going to cancel that out. So then that would leave me with x minus 3 squared equals 400. And now I have it set up in the way I need to, so I can do the square root method. So I'll square root each side, and that's going to cancel this. So I would have x minus 3 equals plus minus, and the square root of 400 is 20. Okay, and now to solve for x, we just need to add 3 to both sides. So I'm going to have x equals 3 plus 20, and then x equals 3 minus 20. Therefore, my solutions are x equals 23 and x equals negative 17. Oh, I'm sorry. Okay, so number 13. Again, number 13 looks very similar to the setup that we need in order to use our square root method. The only thing that's different this time is I have this leading coefficient of 3 out here in the front. And so to get rid of that, what I'm going to do is just divide everything by 3. So then that would give me x minus 6 squared equals 16. And now I have it set up in the form that I need it in order to take to use my square root method. So I'll square root each side. And that's going to give me x minus 6 equals plus minus 4. And now to solve for x, I just need to add 6 to both sides. So then I would have x equals 6 plus 4 and x equals 6 minus 4. So therefore my solutions are x equals 10 and 2. All right. Number 14. Okay, so right away I can tell that this is a perfect square trinomial because when I take my b value here and I divide it by 3, I'm sorry, not 3, by 2, I get x minus 3, or I'm sorry, I get a negative 3, and negative 3 times negative 3 gives me this 9, so that's how I know it's a perfect square trinomial. So my factors therefore would be x minus 3 squared. And this is going to equal 5. I'm just going to bring down the 5. Okay. And now to find my solutions, I'm going to use the square root method. So I'm going to take the square root of each side. So that leaves me with x minus 3 equals plus minus the square root of 5. And then to find my solutions, I just need to add 3 to both sides. So therefore I have x equals 3 plus the square root of 5 and x equals 3 minus the square root of 5. Okay, so number 15. All right, so again, I can tell that number, the x squared plus 4x plus 4 is a perfect square trinomial, because when I take my 4 and I divide it by 2, I get 2, and 2 squared gives me 4. So again, when I divide 4 by 2 here, my b value, and I get 2, I know that my factors are going to be x plus 2 squared equals, and I'm just going to bring down the 15 here. Okay? And now that it's set up in the way that I need it to be, I can now take the square root of each side. So that leaves me with x plus 2 equals plus or minus the square root of 15. And now to solve for x, or to find my solutions, I just need to subtract 2 from both sides. So I get that x equals negative 2 plus the square root of 15, and x equals negative 2 minus the square root of 15. And those are my solutions. All right. Okay, so for number 16 and 17, they're literal equations where we are going to be solving for k on both of them. So for 16, we have g equals 6k squared. And what's going on between 6 and k squared is multiplication. And so I need to divide both sides by 6, because what I want to do is isolate this k squared here. So when I do that, I can rewrite this as k squared equals g over or divided by 6. And now, if you'll notice that this is similar to this right here, it's set up in the form that I need it to be in order to use the square root method. So that's what I'm going to do, is take the square root of each side. So that's going to go away. So then my solutions are going to be k equals plus minus the square root of g divided by 6. Okay. Now on number 17, I have a equals k squared divided by 3. And again, to solve for k, I want to isolate this k squared first. So I need to multiply both sides by 3 so I can get rid of this. So that's going to give me k squared equals 3a. And now that it's in the form that I need it to be in, I can use the square root method on both sides. So then I have k equals plus minus the square root of 3a, and those are my solutions. Okay, and that completes this worksheet on the square root method.